All right, so say given this diagram of a guy falling through the sky. He has a drag force due to air resistance, and he's falling at a terminal velocity. And the question says, if a guy of mass 5 kilograms is falling from the sky, he's subjected to a drag force of 500 newtons. What will his terminal velocity be? So we can start by addressing the question of what is terminal velocity. Terminal velocity is the velocity when our drag force, Fa, is equal to the force from the acceleration due to gravity, mg. So if we draw a diagram here, we have our drag force, Fa, and our force due to gravity, which is the weight force, mg. Use Newton's second law. Our summation of forces in the y are just going to be the drag force and mg. And for the condition of terminal velocity, we just said that drag force is equal to mg, so we can substitute that in. Mg minus mg is just equal to 0. So we get 0 equal to the acceleration, the y, and this makes sense because the person is no longer accelerating in the sky. He is falling at a constant velocity. But what is drag force? Drag force is also called fluid resistance, and it's the force of a fluid or gas or liquid, like air, exerts on an object while the object's traveling through it. And this can be given by the equation here, F equals kv for low speeds, where v is the velocity and k is a constant given by the fluid. At high speeds, this force is given by dv squared, where v is still the velocity and d depends on the shape and size of the object and the density of air. So it's a constant given by the question, and the units for that is kilograms per meter. So we can bring this back to our example. So this is our free body diagram here, and then we can apply Newton's second law equation. If we look at our diagram, we have two forces, the drag force and the weight force. So if we plug those two in, and we already know that the acceleration y is going to be equal to 0 when he is traveling with his terminal velocity. Plug that in and then bring the mg to the other side, and we get this expression here. And we can substitute fd equal to dv squared, and then we can isolate for v. This is going to be the terminal velocity by multiplying both sides by 1 over d, and then we can take the square root of both sides, and we get this for the final answer. This is going to be the terminal velocity to the drag force. This equation is a general equation and can be used to find the terminal velocity of any falling object through any media. So we can apply this back to our example, and let's say that they give that d is equal to 0.27 kilograms per meter, and we apply our equation as so. We know that the mass is equal to 5 kilograms and the gravity is equal to 9.8 meters per second squared, and if we apply our d as well, we get this expression here, and then we can just divide the amplitudes into units, and we get this here, and then we can take the square root, get the final answer. This would be the velocity that the person will be traveling with once the drag force is equal to his acceleration due to gravity in the sky, meaning his acceleration is equal to 0. I want to note that our units make sense. Velocity is meters per second, and we get meters per second, so that's another way that we know our answer is correct. We can also draw a diagram here. So the guy's falling through the sky. He's going to have his weight force and the drag force, and they're both equal to mg when he's under terminal velocity, and then we have our terminal velocity vector here.